evening. This is Jack from SSC Science Tutorial. Today we are gonna talk about math, especially the subject of geometry and shapes, part 1. So some of you might be wondering, why is this topic picked first? Because according to some math teachers in SSC, this is the topic that students generally struggle with the most. I think this is because that 3D shapes are very difficult to imagine or pixelate, unlike lines and equation where you can think about it yourself. So what is geometry? It is a branch of math that the size, the shape, angles, and dimension of things are being measured. Generally, geometry investigates in different shapes, be it 3D or 2D, and its property. So let's start with 2D shapes. Shapes are closed figures that are formed by line segments. What I mean by closed is that it does not have an opening to the figure. A 2D shape is a shape that has length and width but has no depth, which means that in a vector form it has x and y, but the set is 0. Often in shapes that you are measuring, it is featuring line segments instead of lines. And you might think, what is the difference between a line and a line segment? A line is an infinite collection of points that extend both ways, as shown here of the blue line. A line segment is like the line below, which has A point and B point as its endpoint, which means that it can be measured. Now that we have introduced 2D shapes, let's talk about some common shapes and their names. One of the shapes that you are most likely to encounter is triangle. Triangle has 3 sides and 3 angles, while quadrilateral has 4 sides and 4 angles. Pentagon have 5 sides and 5 angles, etc. These 2D shapes can also be known as polygons. So what are the interior angles of a polygon? As most of you know, a triangle's interior angle adds up to 180 degrees. There is actually a formula that could be used, which could apply to every single polygon to get its interior angles. The formula would be n minus 2 times 180, which n is the number of sides that the polygon has. Some of you might wonder, how does this equation work? Now I will show you how this works. A diagonal line is constructed from a vertex to another vertex. You can see that 3 triangles are being constructed. This actually is n minus 2 amount of triangle, and because each triangle has 180 degrees, it has an n minus 2 times 180. Even among the triangles, there are special triangles. For example, the right angle triangle and triangles with special degrees. Right angle triangles are triangles that contain a 90-degree angle. They are very useful as you can perform Pythagoras theorem and sine, cosine, and tangent on them. Special triangles are triangles that has either 45, 45, 90 degrees or 30 degrees, 60 degrees, and 90 degrees. They are very important sine, cosine, and tangent because they are a constant that you can remember. Pythagoras theorem is a theorem that is often used in Form 1 to Form 3. It is a squared plus b squared equals to c squared. In this equation, a and b are perpendicular to each other, forming a 90 degrees angle, while C is directly opposite to the 90-degree angle. Some of you might be wondering how this equation could be derived. Consider this situation below, where there is a square with a length of AB. The area of the square would obviously be A plus B squared, while the area of the square inside, which has the length of C, would be C squared. You could also calculate the area of C squared in terms of AB by minusing A plus B squared by the 4 triangles. The area of the triangle is A times B over 2, which, if there's 4 of them, equals to 2AB. This would mean that C squared is equals to A plus B in the bracket square minus 2AB, and as everyone knows, A plus B in the bracket square is an identity that equals to A squared plus 2AB plus B squared. And then if you minus 2AB, then you would get A squared plus B squared equals to C squared. Now we'll introduce sine, cosine, and tangent. Sine theta, theta being the angle, is equals to the opposite side divided by the hypotenuse, which is A over C in this situation. And cosine theta is equals to B over C, which is the adjacent side of the theta divided by the hypotenuse. Tangent theta is equals to sine theta over cosine theta, which could also mean that it is the opposite side divided by the adjacent side. As I have mentioned before, there are something known as special angles, and these special angles has a unique sine, cosine, and tangent degrees that the teacher is very likely to ask you to memorize. Sine 45 degrees is 1 over square root 2. This is because that the hypotenuse is always a factor of square root 2 more than the opposite side or the adjacent side when the degree is equals to 45. So for example, if the adjacent side is 2, then the hypotenuse would be 2 square root 2. Cosine 45 degree would also be similar due to the reasons I have suggested, and since tangent 45 degree is equal to sine 45 degree divided by cosine 45 degree, then the answer would be 1. For the other special triangle, it has a 30, 60, 90 degree angles. And for sine 30 degree, it is equals to 1 over 2, as the hypotenuse would be 2 and the opposite side would be 1. Cosine 30 degree would be square root 3 over 2, as it is the adjacent side over the hypotenuse. You can see that cosine 60 degrees is actually equal to sine 30 degree, and cosine 30 degrees is actually equal to sine 60 degree. You can see the relationship of sine and cosine would be sine theta is equals to cosine 90 minus theta. Some of you might think that sine 30 is equals to 1 over 2. So if I times 2, it would equal to sine 60. But it actually doesn't work that way. There are combined angle formulas and other things, but I will leave it for the next video. Thank you.